Factorize fully. Yep, it is a lot of different variables here, right? It's not a standard quadratic. So in this case, we actually need to factorize twice. So notice it doesn't say just factorize, it says factorize fully. So that's a little hint for us that we might need to do what's called two-step factorization. So looking at all these variables, so we have what? F, M, G, N. 4 variables. Between the terms, you'll see some overlap. So for example, Fm and minus 2gm have an m in common. So I'm just going to rewrite it. So we have, this isn't the only way to do it, but it's one way. Fm minus 2gm and then minus 6gn plus 3fn. Notice they have an n in common. And now if we just focus on these two terms separately, we can pull out a common factor. So in the first two terms, that would be m, and we're left with f, right? M times f is fm, minus 2g. And for the second two terms, we have an n in common and a 3, right? Between the 6 and the 3. So we have plus 3 n, and we're left with, the first term would be minus 2g, right? 3n times minus 2g is minus 6gn, and in the second term, it would be plus f. Now you'll notice in these brackets, we actually have the same expression. Let me just rewrite the second one so it's a bit clearer. So f minus 2g, right? It's the same. I just swapped the order. And so now we can look at this whole expression and ask, all right, what's the common factor? Well, it is f minus 2g, right? That whole bracket is a factor. So we pull that out the front. And f minus 2g times what gives us m times f minus 2g? Well, that's just m. And then f minus 2g times what gives us 3n times f minus 2g. Well, that is plus 3n. And we're done. If you're unsure on this one, do expand it back out again. As again, that'll take 30 seconds and ensure that you got it correct.